You may still wonder what is inside of this fossil and how we found out this one and from where we got it. So let's start this story. The thing which makes this fossil rare for us is not its lifespan, although it's true. The thing which makes it rare is the horseshoe crab's brain, which we got inside the fossil with ancient arthropods' central nervous system. But this one is difficult for our researcher to make it out of rock, because this time it's the brain that has many soft tissues and it's hard to preserve the brain in any form. In 1 in a million find, if not rare, says evolutionary researcher Russell Bicknell. A fact, a horseshoe crabs have a fossil record spanning roughly 445 million years, although it's much greater than 310 million. But having a long fossil record is one thing for many animals, including the crabs. Fossils of their softer tissues are extremely uncommon to find by us because the tissues tend to degrade far quicker than fossilization can occur. Finding the delicate fatty structure that form a brain preserved in rock is most rare. Only about 20 samples of fossilized arthropod neural tissue have been identified to date. The brain about which we are talking is a fraction of a larger fossil named Eprops danae, which Russell Bicknell found out at a Yale Peabody Museum of Natural History. Eprops danae was originally sourced from Mason Creek, but what makes Mason Creek more special for us? McCoy says it's interesting because the fossils are preserved inside concretions. Most concretions in other fossil beds have no fossils or fossils that are just bones and hard parts. But Mason Creek has really good soft tissues preservation inside these concretions. But how these concretions of Mason Creek make it possible? Here comes our chemistry into our play. Concretions make it possible because they are composed of partially iron and carbonate minerals, which are named siderite, which only form in low oxygen environments. Due to low oxygen environment, the tissue decay time slows down, and due to this preservation of fossil fuels becomes possible for us at Mason Creek. But it's about the process of preservation at Mason Creek. But what about original cycle of process of fossil fuels? The original process deals with multiple steps. The first step, horseshoe had to die. The second step was crab had to be decayed. Third, it should be surrounded by mud with a low oxygen environment. Fourth, now the siderite makes a crab's body coated and to preserve its fragile brain. Lastly, after the brain degraded, the siderite mold was filled in with a pale clay mineral called kyanite, with creating a wide brain structure that stands out starkly on the otherwise tan fossil. Over the time, a sphere of rock formed around the fossil before eventually breaking open in fortunate way. And if you are interested in knowing more about this discovery, you can see the link of article inside the description of this video. Yet, at the end of our video, what value we get from it? The value we get is sometimes our environment can make many changes inside of us than we could make ourselves possibly. So that's all for now, and I will see you on a great day.